All right, let's dive in. We're going to tackle one of the most fundamental skills in all of engineering. How do you take a complex, three-dimensional idea that's in your head and put it on a flat, two-dimensional piece of paper so that it is perfectly, absolutely clear? I mean, how is that even possible? Seriously, think about that for a second. No words, no waving your hands around, just you, a tool, and a surface. How do you communicate an intricate design to someone, maybe halfway across the world, and make sure they get it exactly the way you intended? It sounds like a huge problem, right? Well, the answer is actually beautifully simple. That's it. It all begins right there, with a sketch. This is that first, essential bridge between what's in your imagination and what can actually exist in reality. It's the starting point for literally everything, from a tiny little bracket to a massive skyscraper. Okay, so let's start at the very beginning. That moment where an idea goes from just being a thought in your mind to something tangible on paper. What exactly is an engineering sketch anyway? This definition is so important. A sketch is not supposed to be a perfect, finished piece of art. It's a tool. It's rough, it's freehand, and it's all about the process of designing. You use it to get your ideas down, to share them with others, and to make them better. It's for that brilliant, messy, early stage of creation. And you know, speed is absolutely everything here. We've all had that brilliant flash of inspiration that just vanishes a minute later. Sketching is about capturing that lightning in a bottle. It's fast, it's immediate, and the best part, it doesn't have to be perfect. Okay, so you're fired up. You're ready to capture your next big idea. What do you actually need to get started? Well, this is the great part. The toolkit is wonderfully simple. Anyone can do this. That's pretty much it. A mechanical pencil gives you those nice, consistent lines. Some paper, unlined is great so you're not constrained, and a good eraser. But I absolutely love this piece of advice. Don't overuse your eraser, save your mistakes. Because you know what? Sometimes those little slip-ups, those mistakes, they can spark a whole new direction for your idea. Now, drawing a perfectly straight line freehand can feel impossible, but there's a trick to it. First, you just mark your start and end points. Then, you do a light little ghost pass in the air or barely touching the paper to get the motion right. Then, you commit with a darker, more confident line. And here's the real pro tip. Turn the paper. Don't try to force your arm into some awkward angle. Make the paper work for you. And this is just brilliant. It really shows you the logic behind sketching. To draw something complex like a circle, you start with something simple, a square. You create this little scaffolding, the box, the diagonals, to find your key points. Then you just connect those points with small controlled arcs, rotating the paper as you go. You're building complexity from pure simplicity. It's fantastic. So, okay, you can now draw perfect lines, perfect circles. You're a sketching machine. But even the most flawless freehand sketch has a really serious weakness. One that becomes painfully obvious the second you hand it to someone else and say, "Hey, can you build this?" And this, right here, is the absolute heart of the problem. A simple picture-style sketch is just too ambiguous. Is that hole supposed to go all the way through the part? Is that surface flat or is it angled? Your brain might automatically fill in the blanks, but someone else's brain is going to fill them in differently. And an engineering misinterpretation isn't just a mistake, it's expensive and it can be dangerous. This is the million-dollar question. This is the challenge that took sketching from just a personal brainstorming tool and turned it into a universal language. How do you create a drawing that has one and only one possible interpretation? Well, here's the solution. You move from what's called a pictorial sketch to a multi-view drawing. So on the left, you've got the pictorial sketch. It tries to show you the 3D object all at once. It's easy to look at, but like we said, it can be ambiguous. On the right, that's the multi-view drawing. It breaks the object down into a series of flat 2D views. It might look a little strange at first, but when you put them all together, they describe the object with perfect mathematical precision. No guesswork. So, how in the world does this system of multiple views actually work? Honestly, the best way to get it is to imagine you are literally unfolding the object. It's a concept called
orthographic projection. Okay, I know that sounds super technical and complicated, but the idea is actually really simple. Imagine you shine a light on your object. But instead of the light spreading out everywhere like a normal lamp, all the light rays are perfectly parallel. The shadow that object casts, that's a perfect, flat, 2D representation of that side of the object. No distortion.
And this right here is the golden analogy. This is the key. Picture your object floating inside a box made of glass. You look straight at it from the front. and you trace its outline onto the front pane of glass. Then you move up and look straight down from the top and trace that outline on the top pane. Then from the right side and trace it on the right pane. Now, imagine you unfold that glass box so it's flat. Those 3 tracings, that's your multi-view drawing.
And, for most objects out there, all you really need are these 3 main views. You always want to start by picking the front view. That should be the angle that shows the most important, most descriptive features of the part. Once you have that, you just add the top view and the right side view.
Now, this is probably the most important thing to remember. The placement of these views isn't just a suggestion, it's a strict, non-negotiable rule. The top view always goes directly above the front view. The right side view always goes directly to the right of the front view. This standard alignment is the magic key that lets anyone's brain automatically fold those 2D views back into a 3D object.
So this system creates a really clear relationship between all the views. Your front view is like your anchor, your central view. The top and right views are adjacent to it. You can imagine that 90-degree fold in the glass box between them. And this means that top and right side views are related through that central view. They share dimensions with it, which is how you can be sure that everything lines up perfectly. So when you put all of this together, you get something that's way more than just a drawing. You get a blueprint. You get a truly universal language for how to make things. The real power of orthographic projection is its honesty. It's truthful. Unlike a perspective drawing where things in the distance look smaller, here nothing is distorted. The geometry is pure. If 2 lines are parallel on the real object, they are parallel on the drawing. It is a direct, honest-to-goodness translation of the object. And that, right there, is the ultimate goal. You go from a messy, kind of ambiguous idea in your head to a quick freehand sketch, and finally to this precise system of views. What you've done is create a language of design that is unambiguous, that is accurate, and that can be understood by engineers and builders all over the world. It's an incredibly powerful tool that turns pure imagination into clear, actionable instructions. So I guess the only question left is, now that you have a key to this language, what amazing ideas are you going to bring to life?